Okay. Well, as I said, let's continue with what we have. Today we'll be continuing talking about the introduction for the control system, but let's start by defining what is a system. So any help? What is a system? Any suggestion?
Input-output process.
Input-output process. Well, a system is an interconnection of components, okay, forming a system configuration that will provide a desired system response. Each component can be described by cause and effect. That's basically, we can model the system by a black box. Okay, I have input to the black box and I get an output. The input to the black box, basically, it is what I want, what is my desired output. The output will be the actual one. And in here, this is black box. This black box could be differential equation, could be transfer function, could be state space representation. So basically, I am representing the system by an input-output relationship. Okay, cause and effect. Any question here? Well, let's talk about in here an open loop system. What's an open loop system? What's an open loop system?
There is no feedback.
It has
No
One way.
feedback.
One way.
Okay, basically in the open loop system, I have process and I have desired outputs. I hope my actual output will be equal to the desired output. But sometimes it doesn't match. In that case, I cannot do anything. I cannot do any correction. I hope my system will work perfectly, but if it doesn't, then it doesn't. Okay? Can you give me from real life any example for open loop system?
Toaster.
What?
The op-amp.
Op-amp. In the op-amp, you don't, well, the op-amp will give you a gain, but there is no, no, sometimes the op-amp, I think it has a built-in feedback, you can have a built-in feedback. I think you can.
Maybe in a communication system, when you receive a message, a modulated message.
Okay.
And then you want the output. In the simple communication system, there is no feedback, kind of feedback here.
Okay, okay.
You just receive the message, modulated one, and then you demodulate the message, and then you extract the output.
Okay. It's a toaster. You know what's toaster? You have bread, you put it in a toaster, it will stay for a certain time, and it will come out. Okay? So suppose you start with two breads for identical toasters. One is dry and one is wet. After you put them, let's say for 30 seconds or one minute, do you think they will both have the same degree of darkness?
Again, Doctor, the question.
The question
No,
is,
no.
I have a toaster, I will make a toast. Okay. In the toaster, in the machine. Okay, it will stay for, let's say, 30 seconds. And it will give you the bread, your bread. Suppose you start with two identical machines, and one you put a bread dry, and the other is, wet. Do they reach, after 30 seconds, the same degree of darkness?
No, of course.
No.
Okay, so basically, take another example. Washing machine. You bring, again, two identical washing machines and put them for certain time, or one machine, and you run it for, let's say, 30 minutes. And you put in the first set dirty clothes, but not extremely dirty. So they will come by a certain degree of cleanness. Suppose for the same machine, you put another set of clothes which are dirtier. You have kids, you know, they play in the road and, you know, they have mud or whatever. Do you think if you put them in the, for 30 minutes, you'll get the same degree of cleanness?
Of course
No.
not.
Of course not. So basically what we are saying, if the process depend on time only, then it's going to be open loop. Think about traffic light also. If the traffic light is not smart, some of the traffic lights are smart, you will see in one lane is very congested while the other lane is empty because they are giving equal time for the lane, different lanes. If it is smart, if the, you know, if the traffic light is smart, they put a camera, they will sense the other side. If there is no car, they will give more time to the other, you know, part of the road. So open loop system is a system in which, okay, the output is not fed back. It does not go back. You don't compare your output to the desired one. You hope it will work, okay? But if it doesn't work, it doesn't work. So what people will do, we will use what we call feedback. In the feedback, what do we have? In the feedback, or the closed loop, okay, you have the desired output, set it to the system, and now you know, look into the actual output. Through a sensor, compare it to the desired one. If it is matching, there is no error, and I don't need any controller. The process will work. But if there is an error, the controller will, you know, act on the process, and it will try to adjust such that I will, you know, reach the desired level. Example in here, any example?
Air condition.
Air condition, room temperature. You set, let's say, the desired, let's say 20, 22, okay? Depending on if you are a father, you try to set it 23, let's say. If you are a son, you are not paying the bill, electricity bill, you set it on 18. So anyway, whether you set it on 18 or 20, you know, measure, you have a sensor. The sensor will measure, and then it will feed back. If there is a difference between the actual and the desired, then the compressor will start working, and you will have more cooling in the system. If you reach the desired one, there is no error. The controller or the compressor will, you know, stop working. So in here, what you need sensor, okay, and compare and comparator. Well, so generally speaking, we will be using feedback system. It doesn't mean that we don't use open loop system. We do use open loop system. What's the advantage of open loop system over the feedback system? Any advantage?
Simpler.
Simpler.
This component.
What else? Cheaper. You don't need to have a sensor, but sometimes it's not accurate. So most of the time, we will be working with the closed loop system. Okay, what do we have in here? I have closed loop system, but I'm introducing certain disturbance. What's a disturbance?
Noise.
The disturbance is unwanted input. Can we have an example?
generator.
Microphone.
What?
Microphone.
A generator.
Generator? Where is the disturbance in the generator? Yeah, I think you're right.
Oscillators, not generators.
Okay, look, maybe, an easier, an antenna. You are putting an antenna in the roof.
Yes, yes.
What do you want to do in the antenna? You want to position the antenna through the motor in certain direction. And suppose there is a wind in the roof. The wind try to, put a torque such that it will try to reposition your antenna. But if your system, if you have good control system and the disturbance, of course, I mean, with a reasonable power, your system try to adjust such that the effect of the disturbance will be minimal. Okay, in that case, we call the system the disturbance rejection. That even though I have disturbance, the actual output is going to be almost equal to the desired output. So this disturbance is unwanted inputs. If you are also, having cruise control, and all of a sudden, there is a truck, okay, pass beside you, what will happen? What do you feel?
Feel that you want to go to,
there
feel
will
the
be
effect of the
certain, your system, depending on your car, the car could shake a little bit.
Yes.
Or if you have wind, definitely the driving is much harder.
Doctor, there is a question here.
Yeah.
What is the main difference?
كيف?
Between the controller, what is the main difference between the controller and the actuator?
Okay.
Yani what is
the actuator?
The actuator and the controller.
The actuator. Think about you have a water tank. The actuator is the valve through the input is coming. Valve.
يا عيال معتز حبي برد ترى.
فراس
ولا ايش الهرجة انتم بردانين؟
فراس يا شباب
الله يعافيك.
فراس عارف
ما في نوم بتروح بقوم تروح مو تروح ايش بصادق
اعطيه ميوت يا دكتور.
كيف؟ الميوت. Okay. Well, where this is this is a disturbance. Okay, the actuator, look, as I said, the actuator is the, if you have water tank, the valve is the actuator. The controller is the motor. The motor will drive the actuator, okay? But look, most of the time, we will put the controller and the actuator together. But technically speaking, your question is absolutely correct. The actuator is the, it is the either a mechanical system, which is the valve, or could be an electrical system. The controller is, what it will do to the actuator. It will make the actuator will be on and off, or it will, rotate in certain direction. So the actuator could be mechanical, and as I said, I gave you the example of the, the valve in a water tank.
The controller, Doctor?
The controller is the motor.
The motor, I see now.
Okay.
Yes.
Well, you could have. Yeah.
Doctor, a disturbance, does it have to always happen between the controller and the actuator, or can it happen in any part of the process?
It could, a disturbance could be anywhere in the system. We are modeling it in this way. We are modeling the disturbance as another input in the system. we are positioning it in here. But you know, it is, I mean, disturbance, it is, you know, modeling of another input. I am summing all the, you know, unwanted things, and I'm making it as, you know, a new input to the system. I could have also noise in the measurement, in the, you know, the device, you know, the sensor could have certain noise, and that will affect my performance. So a good feedback system should also will not be affected by the noise or the disturbance. Okay. Now in here, well, this is a loop. I could have more than one loop. I have an inner loop and outer loop, and each one, it has its function. Now in this system, tell me how many input I have and how many outputs.
One input, one output.
One input, one output.
We can say main input, yeah.
What do I mean by input?
I mean, Doctor, main input.
Yeah, well, it is one input.
Yes, yes.
The other one, this is inside. No, the external input, the input which will drive the system. This is an input. The internal one, this is not an input. Unless, like, for example, if we have in the case for the previous one, you could think about the disturbance as another input. So if this is the case, I will call my system as single input, single output. Okay.
This is in contrary or the opposite of multi-input, multi-output, right?
We
New
could
system.
have multi-input, multi-output. Can you give me an example of multi-input, multi-output?
دكتور الانتنة المودم سيستم مثلا receives many antenna.
كيف؟
ما ادري هذه يصلح المثال ولا لا، قاعد افكر انه الانتنة the modem
ايوه.
it receives many antenna due to the path reflection.
Now, wait. Suppose, you know, in the example which I mentioned, I cited, you have one antenna and you want to position your antenna in certain.
Yes.
And there is.
No, not this example. Not this example. Can you hear me, Doctor, very well?
Sometimes now, yes, I hear you now well. Yes.
Yes. So maybe due to the connection. But the idea is basically, if I have a modem, right, an antenna,
Yes.
we have different antennas, 4 antennas, for example.
Okay.
So we will receive the signal, the wanted signal, by different antennas. So we will have multi-input basically, because the received signal will be received by different path.
Yes.
You know, due to the path reflection.
Okay.
So this might be a multi-input, but a multi-output.
This is okay. Yes, you could. But a simpler one, look at this one. How many input I have?
Oh, 2 sources, you mean, yeah, 2 sources.
Yes, I have 2 sources.
And you have outputs at each passive component and active component. Yes.
You could have, now the output, you define it.
Exactly, yes.
One output, which is the, let's say, IL in here, or 2 output, this is VC2, and this is VC3, or VC1, sorry.
Right.
So in this case, I have 3 outputs and 2 inputs. This is what I mean by multi-input, multi-output. Okay?
Doctor, could you repeat the output and input in this example?
Well, in this example, what do I have? I have VC as input, voltage source, and let's say IS, a current source. So I have 2 sources.
Right.
Okay. Now, the output, it depends on what I want. I can define IL as an output, VC2 as an output, VC1 as an output. In this case, if I define it in this way, I have 3 output and 2 inputs. Or suppose I have I'm interested only on IL. How do I solve this system? What do? We use superposition, if you remember.
Yes.
You can do it by mesh analysis, nodal analysis, whatever. But what's important I have in here, I have one voltage source and one current source. And as I said, depending on the question, if they ask you to find VC2, let's say, so they are asking you about one answer, one output. But if they ask you about IL and VC2, then they ask you about, I will have 2 input, 2 output, and so on. So the output in the circuit, you determine the output. The input in here, it is given to you already. Okay? Now, in general, this is the way, we put them. I have a controller, and I have many input, measurement devices, output. So this is, this is the way we vision the multi-input, multi-output system. Well, when the control system started with, very early, okay, in the ancient years, people use control system. If you think about, the pyramids, how the Egyptians built the pyramids, how did they put the huge rock up? Okay, but theoretically speaking, or as a process, okay, it started in the 1769 with the Watt invention of the steam engine. Then they start, systematically, in the process. And then, as we move, they start developing many things, We are still using some of the things from 1927, like body, and 1932, Nyquist. As a matter of fact, in this course, we will be studying we will be checking the stability of the system by using Nyquist method. Or we will do the body plot diagram based on body work. Of course, as we move, things, develop, okay? And now, these days, what is different from the old time, for example, in 70s, I studied the course, more or less the material are the same, but in here, the component, what's different is the computer component. For example, now we are using MATLAB. MATLAB, you can program the entire course through MATLAB. So the computer part is changing. The system become, you can, analyze, you can design more complicated system, more complex system than what we people used to do because of the, the mathematical power or the computing power was, very minimal. Now with the computer, with the supercomputer, we could do a lot. I'll leave yes.
I don't want to interrupt you for the flow, but just a question comes to my mind about the Nyquist, because we have studied Nyquist back in 370, and I'm sure that you are aware of that, which we use the Nyquist criteria for the sampling. So the sampling frequency has to be double the frequency of the signal so that we will not miss any information, right?
Yes.
So is that related to the Nyquist?
No, it is going, no. In there, the Nyquist rate is a little bit different from what we will be studying in here. In here, we will be studying about if I have transfer function of a system.
How can you make it, how can you know it's stable?
How do I determine whether this system, okay, suppose I have this closed loop system.
I see.
Okay, this is transfer function, let's say. You are giving me this transfer function of the open loop system, and I would like to study the stability of the closed loop system by Nyquist criteria. No, it's a little bit different. And there you are talking about Nyquist rate. Yes, the sampling. No, in here, no, it's a little bit different.
I see.
It's a little bit different. Okay. Well, let's come back to the modeling. This is an open loop system. What is my desired output in here?
The water in the level tank.
which is basically h, the height.
Yes.
Okay, so the height is my desired output. Okay, basically I'm using, at home we are using, you know, the water through V1. Okay, how do I check if I am, you know, having the desired level or not? And V2 set, let's say, at certain level. How do I check if I'm having the desired level? What do we do?
We put sensor an H.
No, wait. No. This is, if you put sensor, now make it a closed loop. Now I'm talking about open loop. You are jumping, you are absolutely right. You are jumping to the closed loop. But now in here, how do we check? Well, every once in a while, we go and check the level. Or if you don't check, all of a sudden you'll discover you don't have water at home.
Yes. You have to do it manually. Yeah.
So basically, in here, every once in a while, you send somebody to check the water level. But in here, the accuracy is not going to be that much. I mean, you check if the water level not as what you want, definitely there is no precision, okay? Because you are looking at it. You don't know whether it's actually reached. So in this case, basically, I can think about it as an open loop system, and I can model it as in the following block diagram. The desired level through V2 and the operator and the person who will see, you can adjust the opening of V2, and then you get the output. But as I said, in this case, your system is not very accurate. If you want to make it, you know, automatic, definitely you would put a sensor. And what's your sensor? What is your sensor?
عوامة
العوامة, the float. This is your sensor. And I have problem with my pen. Okay. So this is your sensor. Now, the sensor will check, again, the desired level is H. Okay, the desired level is H. If I'm reaching the desired level, then there is no error between the actual and the desire, and there is no signal. Once the float is down, it means that the water level is less, then a signal will come to the power amplifier to you know, start the motor. The motor will give the signal, will try to adjust the valve. Okay, it will try to adjust the valve, and this is my actuator. Okay, then the system will work. You will see that at home, if the water level is not reaching what you want, you will hear the motor is operating. But if it's reached, then the motor should, you know, stop working. Unless, of course, I mean, sometimes maintenance you have to do. Sometimes the float is not working, or the sensor in the motor is not working. But generally speaking, this is basically, you know, a feedback system where I can model my feedback system in this way. The desired input, the actual input, I compare the actual input with the desired one, then I will through the controller and I will adjust my system. So I can make and this is basically what everybody is doing at home. You have the float and you have the motor, and it will operate automatically. Let's take another example. In here, we are talking about the steering control system. What do you want to do in here? What you know, what is your desired output?
Go straight.
Go straight. Okay. So this is your desired direction, let's say. But suppose all of a sudden you have a car in here. What do?
You have to brake.
brake, or
Go
if you have several lanes,
yes,
you will do correction through.
exactly.
Okay, and then
This gives the idea of the autonomous cars.
what? Yeah, now this is what they are going to do.
Yes.
You-
Yeah, the autonomous cars. I think it's full of control systems, right?
Yes, but it doesn't stop. The car will not stop because okay, look, the using the what's going to come, definitely there will be very complicated system, but that's what they are going to do, and I think they started already. But suppose you are driving a car, okay, and not okay. Suppose not necessarily that you have a car in front of you. You are in a road where there is a curve in it. So what do? Do you leave the steering wheel as is, or you try to bend? You try to change. Okay, because if there is a curve in the road, you are in the highway and you want to take an exit. What do? You have to
turn the wheel.
Yeah, okay. So
I
basically,
will show you. You have to make a signal, which most people do not do.
no, but wait, no. What I'm saying, okay, no, I'm saying that you will be part of the control system. You will be your vision will be the sensor. You will sense and you send signal to your brain, then you will change the steering wheel. So you are part of the control system. So basically, if you look at this one, basically I need the actual system or the desired one is the black one, but the actual one will be around the desired one. If you are moving straight and there is nothing in the road, definitely the desired and the actual will be the same. But sometimes, depending on the on the road condition, on many conditions, you will try to adjust the the system. And then this is you think about it as a feedback system. Okay.
Doctor,
Yes.
here the driver is the controller.
Yes, it's part. Yes, exactly. Exactly. And now in the in the next generation of the cars, they will put the sensors and the neural network possibly to act as driver. This is where the artificial intelligence will come, and we don't have to learn driving, and we don't need driver anymore at home.
But it has, Doctor, of course, certain risk. It's not going to be easy at all, especially with a lot of projects going on in streets and such. So
Everything started from something, and then once the human is very intelligent. You adjust, okay? You do the thing, and you see there is a certain problem. You adjust. A neural network, okay? Now look, wait. Look at when you use Google now. Google sometimes it gives you several options.
Yes, right.
Using for driving,
And sometimes, Doctor, it gives you road. If you follow, you will go to the end. You cannot reach.
No, look, this is true. This is true. But also it can, if there is an accident, okay, in front of you, and there is congestion in the road, it can give you signal.
Yes, right, of course.
Definitely. I mean, it is. Look, it's not perfect, but it becomes accurate.
Right.
Look at the war now. Look at the war. They used to have the fighters. Now, drone is used, and drone is effective.
Well, there is the main issue with the autonomous cars. Usually, they say that people will not give the trust for a machine to, will not give their lives for machines to control.
Look, I am sure you are more, expert than me in using the mobile device, the computer. and I'm sure your son, inshallah, in the future. Now look at maybe if you see your brother or your nephew, or he is what, 6 months, and he can work in the mobile.
Yes, right.
Okay, so look, we used to read our textbook. Now people are preferring reading in the net. So it will adjust. There is certain I agree with you. I agree with you. It is not easy, okay, but this is the future. This is the future. Well, God knows in 2050, let's say, you will be alive, inshallah, and remember me. Okay, thing will be changing. I mean, look, the mobile. Who was, in the 70s? If you see somebody walking in the street and talking to himself, you say this guy is crazy. Now you are putting the headphone and you are talking with somebody maybe in the States or anywhere in the whole world. This is, you cannot imagine in the 60s or 70s. Now it is happening. So artificial intelligence is coming. It is very dangerous, but it is coming. Okay, let's move.
دكتور
Yes.
معلش بس ليش مو الدرايفر هو الاكشويتر؟
The driver is the actuator. No, the steering wheel will be in that case the actuator. The driver is, is the controller. It will. And how do you change? Okay, how do you change it? How do you change the direction? You need mechanical.
دكتور الحين الاكشويتر هو الديفايس.
الديفايس الميكانيكال ديفايس اللي يتغير. يعني اعطيتك الاكزامبل حق الووتر تانك، الفالف هو الاكشويتر.
يعني الاكشويتر يا دكتور هو عفوا الكنترولر هو يعني response to the correction factor.
The correction, but the what will do the action is the actuator.
Is the actuator. It will give them the instruction.
Yes.
For the actuator, and the actuator will do the rest.
Will do the job. Yes, that's correct.
Okay, it's good.
Now, شباب, it's very interesting وصراحة this is great. But أيضا I realize, in the online, I am a little bit slower. Okay, so we have to move a little bit. Now, what we want to do now, this is this is basically what we are going to study, the mathematical model of systems. So basically, what we are going to do in the rest of this lecture and next lecture, we will be talking about mathematical model, okay? In order for me to do certain things, to do certain calculation, I need the mathematical model. The mathematical model could be differential equation, okay, for the system, and we will be studying mechanical system as well as electrical system. We will be talking about transfer function of system, and then we talk about, the MATLAB. How many of you are, well, I hope all of you are familiar with MATLAB, but if you are not, we will, I think in the first experiment, you will, start learning the MATLAB command. As we move in the semester, I will give some command and I will give you the homework. Usually it contains some problem that use the MATLAB. In the project, inshallah, definitely you'll be using MATLAB heavily. So let me start with the mathematical model. What's the model? Okay, if I want to, obtain a quantitative description for the system, I must have certain mathematical model. So the mathematical model usually, okay, it is differential. It could be, starting point. Our starting point most of the time will be a differential equation for the system. Okay, it will give the, it will give you the behavior of the system and how do you, how do you build this system. Okay. Well, if you have, usually if you have physical system, you will use physical law. So if you are talking about, circuit, if you are talking about electrical engineering, what do we use? What are the, laws which we use in, describing, let's say, circuit? What do we use?
Ohm's
We
law.
use KVL and KCL.
KVL, KCL. Ohm's law part of, within the KVL, KCL. How about if I have mechanical?
Newton's law.
Newton's law. Okay. So basically, if you have a physical system, we are going to start with some physical system, simple physical system, and then we will be using both, Newton's law and, as I said, KVL, KCL. Now, suppose I have mechanical system. Now, what's Newton's law? Newton's law, basically, if you have a system, the summation of the forces must be equal to mass times the acceleration. So if you have a free body diagram, you will look into the forces that acting on the system, okay? And then the summation of those forces must be equal to the mass times acceleration. So basically, when you put a force, you are moving the system. This is in the linear motion. What will happen if I have rotational motion?
Torque.
The torque. So in the rotational motion, the summation of the torque must be equal to the moment of inertia times the angular acceleration. Okay, so this is the basic thing in here. Let's start by this system. What do I have in here?
Spring system.
Mass,
Mass
okay,
spring system, yes.
hang by a spring and in a wall. So if you start moving it, there will be certain friction. Now, can you relate this one to a physical real life? I mean, this is definitely, I mean, you have a mass and you put it in a spring, but where is the application for it in real life? Go to the car. Where is this in the car?
Suspension system.
Exactly. The suspension system.
Cylinder.
Okay, no, the suspension system, no. Where do you sit? Okay, you want to sit comfortably in the car. So, okay, you are sitting, down, you will sit on spring. There's a spring and also shock absorber. If you are moving in straight, smooth road, okay, you are you feel comfortable. But if there's a bump in this in the road, then the shock absorber and the spring will, absorb this shock, and then you don't feel that much. So basically, you can think about this system in, this is, in the suspension car. So, okay, suppose I have this system. How do I model it?
Newton's law, right? The mass, the force
okay, so
balance.
basically, suppose I have the mass.
Body diagram, free body diagram.
Okay, this is the mass. What are the forces acting on it?
We have the source force, which is R of T.
First of all, the force, the input.
Gravity.
Okay, the gravity. What else?
And the spring force.
The spring will try to pull it up, and the friction. The force in the spring will be proportional. Okay, suppose this is my y. This is the distance I'm moving downward. And look, I'm not going to consider the gravity in here. Why? Because look, I'm assuming I have the mass before I put my force. The mass, it is, hang in a spring, so it will reach certain equilibrium point because of the gravity. I will assume I am at the equilibrium point and my measurement from that point. So I don't have to worry about the gravity. Okay, so basically in a neat format, let me erase what I put in here. Okay, so basically I have, this is the force, okay, the motion from this point, this is the force due to the spring, and this is to the friction. Now, what is Newton's law in here? So what do we have? R of T minus what? R of T minus
KY and BY.
KY minus BY dot equal to the mass times the acceleration. What's the acceleration will be in terms of y?
Y double prime.
Y double dot. So this is basically a Newton's law for the system. And this is basically what I'm saying. Put it neatly, so this is what you have. This is the differential equation which describe the second order system. What is the order of the system in here?
Second order.
Second order.
Okay, so this is basically a mathematical model. Let me go quickly to another example. Suppose I have this example. This is circuit. Okay, suppose my output is V and my input, okay, R, a current source. How do I write the differential equation for the system?
KCL.
What?
KCL.
KCL here. Okay, with KCL, what is the current here? KCL, the total
V over R.
current. So the current in here, V over R, plus what's the current in here?
C dV by dt.
dV dt.
Yes.
Plus what is the current in the
1 over L, the integral of V
1
dt.
over L integral of V of t V dt, let's say. This must be equal to
the source
of t. The summation of the current going out equal to summation of current moving in. So this is the differential equation. Of course, I can get rid of the integration by doing what? By taking the derivative, and again, I will get a second order system. Any question here? Or in the previous example, we have a couple of minutes. Any question here? Okay, so the other example, as I said, those are the two examples. We will be using, we will build on this knowledge when we move further. We could later on, we talk about a little bit more complicated system, which is the DC motor or DC generator. Okay, but we will be, I think, let's, stop at this point. If there is no question, I think we'll be stopping in here. If there is a question, I would be more than happy to, answer the question.
Doctor, I have a question.
دقيقة بس واحدة, I will be with you. Yes.